This is the Graphing Motion Lab when I pull my version up. And when I click on paddles, it will show me what the settings are. So paddle period is 1 second, and I can increase or decrease. And then paddle strength, you can increase and decrease it. Combined mass and river current. And so with these settings, I can start, and I'm going to pause it at every moment, right? So about 5 seconds, I'm going to say this is 5 seconds. I'm at 0 meters, or my boat guy is at 0 meters. And then I'm going to keep pausing at each of the marks, and I'm going to get some sort of information that I can capture into my table. And so I'm just going to keep going. And then I'm going to stop it at 100 meters. Okay. For our Desmos graph, I'm going to add in, I'm going to add a table. And for the x-axis will be time, which is labeled here, and the y will be our position, so where it's located on the river. So for the first one, at 5 seconds, I decided that my boat was at 0 meters. And then when it was 9.5 seconds, I saw that my boat was at 25 meters. And then when it was 13.7 seconds, I saw that my boat was at 50 meters. And then when it was 2 seconds, my boat was at 75 meters. And then when it was 22.6 seconds, my boat was at 100 meters. So now you're going to see that I have like all my green dots lined up. And to show that it might be going in a straight line, I am going to put in the code, or like we have to program our graph to show that it is going in a straight line. And for that, it's going to be Y1 squiggle, which is the key when you press shift and then the key next to the 1 number, mx1 plus b. And so then it will create this line, which is red. You can change the color if you don't like the red color. Maybe you like purple better, okay? It doesn't really matter. So it's going to give us this information about my graph. It's going to tell me that the slope is 5.6942 and that the y-intercept, which is b, is negative 28.58. Screenshot of your graph, and what should have happened is that you have your name up here in the corner to show that you're signed in, so I'll know that you made your graph, and that you've also saved your graph under a name, so I called mine boat velocity. And now we're going to annotate our graph, right? We're going to find some information on it. So maybe before I do this, I forgot to tell you, this is where you go to label your graph. All right, so you'll press this down and then you'll find a place where to put your labels for your x-axis, which is time, and your y-axis, which is position in meters. So it's really important that you put the name it's called and the units. Next, we're going to talk about our slopes and our y-intercept. So our slope m right here is going to be found here where it says m is equal to. So m, which is slope, is equal to 5.6942, which I'm going to round to 5.7. Now my y-intercept, which is b, so b is our y-intercept, and can be found right here, is at negative 28.58, which I can round to negative 28.6. 6. All right. Now we're going to talk about the verbal model of what this means, right? So all graphs have a meaning, and the verbal model will just be the meaning of that graph using words. But before we do that, let's do the mathematical one first, since it's so easy and it's already here. Okay, so the Desmos, this is our Desmos program, the code that we entered to get our straight line. So this is what we entered in Desmos. So y1 squiggle mx1 plus b. And what that translates to in algebra is y, or let me rewrite that. What that translates to in algebra is y is equal to mx plus b. And this is what we call the linear equation. Okay, and so that's why it makes a straight line, because it's the linear equation. Now we'll leave our lab equation for later, and let's kind of go through this. All right, so the slope of our line with the units is, our number is my number is 5.7. And if you remember, slope is rise, the change in rise over the change in run. So the slope for rise is meters, and the units for rise is meters, and the units for run would be seconds. So our unit would be meters per second. And what this means, right, what this particular part means is, for every 1 second, the boat travels 5.7 meters. Now we can say in the positive direction, but the boat was technically moving to the left, so we'll just leave it there. But it really did travel in the positive direction, so we can say, actually, you know what, we'll go ahead and say that. So it moves 5.7 meters in the positive direction. All right, so now we'll go back to our y-intercept, which is negative 28.6. And so our y-intercept here was negative 28.6. And y-intercept means the starting point of, you know, when x was equal to 0. So when the time was 0, the boat was at 28.6 meters behind the starting line. So actually, that's what this tells you. So at time 0 seconds, the boat was 28.6 meters behind the starting line. All right, and now our verbal model is, okay, so our verbal model is, the boat started 28.6 meters behind the starting line. And travels 5.7 meters forward for every 1 second. And now our lab equation is just going to be just that. We're going to replace y, m, x, and b with what it actually means. So we're going to go back here. And if you remember on our graph, Our graph here is the x-axis is no longer called the x-axis, it's called time. Okay, and our y-axis is no longer called the y-axis, now it's called position. And we have a line here, which is our slope, which tells us how fast the boat was going, so it's a speed. So the velocity of the boat. And the y-intercept tells us where the boat started. So the starting position of the boat. Okay, and so here we're going to now, next to each letter, write what it represents in physics terms. Y and X should be variable names, and M and B should state exactly what they represent physically about the boat's motion. So y-axis is our position. So position, and the symbol for position is X in meters. And our slope was velocity. And the number that we got from that is 5.7 meters per second. And then our x-axis, which here says time, so time, and the symbol for time is T with units in seconds, and the y-intercept for that is the starting position or the initial position. And if you remember from my graph beforehand, right, so I got that information from here. The y-intercept is at negative 28.6 meters. So now I'm going to rewrite my whole equation. I'm going to rewrite it, and instead of y, I'm going to replace it with x for position is equal to, I'm going to replace slope with my velocity, which is 5.7 meters per second. And then I'm going to replace x here with what my x-axis stands for, which is time. And then I'm going to replace my initial position with the real number, which is negative 28.6 meters. So this is the lab equation I'm going to put on the previous slide. So x is equal to 5.7 meters per second times time minus 28.6 meters. So I'm going to do x for position is equal to 5.7 meters per second times time minus 28.6 meters. And so once again, this is my y-intercept right here. This is my slope right here. And then my x-axis turned into what I called it, which is time. And my y-axis is position. And so that concludes our graph analysis.